A logarithmic equation of the form logarithm to the base a of u is equal b, where b is any real number, and of course a is positive and different than 1, can be quickly solved by changing it to exponential form. However, since this equation contains logarithm, we'll have to make sure first that this logarithm is well defined, and therefore we have to find the domain of that function. So let's look at the example. We are to solve the equation logarithm to the base 5 of x squared plus x plus 4 is equal to. We'll start with the domain of that function. We have to guarantee that that logarithm is well defined, and therefore we'll have to make sure that x squared plus x plus 4 is positive. To solve this inequality, which is a polynomial inequality, we'll solve the equation x squared plus x plus 4 equals 0, and then we'll determine the sign of that left-hand side on the number line. So if I want to solve this equation, this is a quadratic equation, I cannot factor it, so I will use the quadratic formula. It's negative b plus or minus square root of b squared minus 4ac over 2a. And if we plug in values for a, b, and c, we'll get negative 1 plus or minus square root of 1 minus 4 times 1 times 4 over 2. We can quickly see that the expression within the radical is negative, and therefore there is no solution to this equation. So next step in solving inequality like this is to make the number line, plot the zeros, and figure out the sign of the expression. But in this case there is nothing to plot, because there are no solutions, so we just need to determine the value of the expression by choosing one point, and you can choose value of x equals 0. The value of the expression is 4 is positive, and that means that x squared plus x plus 4 is always positive. So the solution or the domain is the set of all real numbers. And therefore, we don't have a restriction on this equation on values of x, and we can go to step 2 to use the exponential form of this equation to solve that equation for x. So since we have the equation logarithm to the base 5 of x squared plus x plus 4 is equal to, if we rewrite in equivalent exponential form, we'll have 5 squared is equal x squared plus x plus 4, or x squared plus x minus 21 is equal 0. So the equation, logarithmic equation, reduced to the quadratic equation, which we have to solve now. That equation again will not factor, we'll have to use the formula. So x is equal, negative b will be negative 1, plus or minus square root of b squared is 1, minus 4 times 1 times negative 21 over 2 times 1, which becomes negative 1 plus or minus, within the radical we have 85 over 2. So these are the solutions. Since there is no restrictions on the domain, any value of x is good in the equation. Therefore, these are the solutions of that equation.